So number 3, 5, and 6, obviously very strange. I trust that you guys understand the nice, bless you, the nice simple y equals mx plus b ones pretty well. So we're just going to go over the special cases here. Now 3, do you see a y in number 3? Yeah. Do you guys see the letter y right here?
Yes.
Yes. Do you see the letter x?
Yes.
Yes. So this is not going to be one of our special case lines. A special case line being a vertical or a horizontal. This graph is going to be somewhere in the middle at some slant, right? Now, if I have a single x there, what number is invisible, but I really know it's in front of that 1? Or in front of that x? 1, right? I said it. But yeah, you guys know it. We got a 1 in front. Do I have a b value off on the end?
No.
No. So that's like saying I'm adding what?
0.
0.
You can add or subtract 0 either way. It'll still be the same.
That's right. Because 0 can't be negative. So we just call it 0. So my m is 1, my b is 0. This is where a lot of people got confused. How can I turn 1 into a fraction? Put it over 1. I saw some people putting it over 0. Definitely don't want to do that. 1 as a fraction is 1 over 1.
Yeah.
3 as a fraction is 3 over 1, right?
Yeah.
So my slope is 1 over 1. My slope is also rise over run. So what direction am I going to rise 1 unit?
Rise 1 unit. Run 1 unit.
I'm going to rise in what direction am I going to rise this 1 unit?
Up.
How do I know I'm going up?
Because it's positive.
Positive. What direction am I always going to run?
Right.
To the right. Where am I going to begin by making my first point?
0.
That's what B stands for. Begin. Here's my y-axis. And I'm going to begin by making a dot at 0. There's my beginning point. From 0, I'm going to go up 1 and right 1. From this 0, I'm going to go up 1, right 1, and make a dot. What do I do now?
Continue doing that.
Repeat it. Up 1, right 1 dot. Up 1, right 1 dot. Boom, boom. You can follow the pattern. You guys have eyes. Okay. Anything else I can do?
Reverse.
Tia?
Yeah.
Reverse. I can go back to my beginning.
And just go.
And instead of going up 1, I'm going to go down 1.
Down.
Instead of going right 1, I'm going to go
Left.
left 1. Boom, boom.
Keep doing that.
All the way down as far as we can. We want a nice, precise line all the way through
And
my
then
graph.
Add the arrows at the ends of the
Yep.
line.
A lot of you guys forgot to put arrows on your mapping diagrams on the test.
That's
Unfortunately.
crazy.
Tyler?
Do you have to put the fraction for the m?
For this, yes. Because this lesson, what's that? Like right here you're talking about?
Yeah, like what if we just put m equals 1?
Does your line look like this?
Yeah?
It's fine.
Okay.
Yeah, that's fine. As long as you understand what we're doing. Now, Mr. Church, that's so many points. That's so much work. That's so annoying. Why do I have to do that? Well, let's pretend this is the same one, right? Let's say you begin at 0, you go up 1, over 1, and you make a dot like that. Okay. I only need 2 points, so that should be fine, right?
Yeah. Just do that.
That is
Did I go through those 2 red points?
Yeah.
Yeah.
yeah, but
But what do you notice about this line compared to this line?
It has less dots than the other one.
it's like it's off by 1.
It's off. Look where we should go through both corners of my graph. Did I hit both corners of my graph?
No.
No, then it's wrong. It's not the same line. It's slightly different. This would have a slope of like, I don't know, 1.1 or something. So in order, if we're doing this by hand, we have to make as many dots as will fit so that we have the most precise line. This is not very precise. It's close, but not close enough. We want to be exact. That's why I ask you to make all the dots, because I put 2, I went through them, it looks like they went through them, but it's a little bit off. Question again.
Can't you just make it more precise by like just like the line in order to be like going through like each dot in the center?
What do you mean?
Like couldn't you make it like more precise instead of like going through each dot like on the side you could go through it in the center?
Like going through the center of these dots? I did go through the center of these dots.
You went through the side, I'm like it was a 1.
Okay, well now it looks like I went through the center, right? The point is, you should be making as many points as possible because we're human beings, and these are small little graphs. Yes, you can get very, very close with a ruler and your pencil and your hand, but you can't get exact. Well, you have a less chance of getting exact if you have less points. That's what I'm trying to say. If you have a problem with that, I apologize, but it is what it is. Number 5 says y equals 5. Here's a little trick for these special cases, right? So first off, do you guys see a y in this equation?
Yes.
Do you guys see an x in this equation?
No.
No. All of a sudden, I know that something is wrong with this. This is either going to be a flat line or a straight up and down line, horizontal or vertical. How do I know which one it is? We don't even really have to think that deep about it. It says y equals 5, right? So I'm going to go to the y-axis. I'm going to find 5, and I'm going to make a dot.
Yeah.
Everybody with me so far on that?
Yes.
Now, what letter are we missing from this equation again?
Uh,
There's no x. So the line that I make is never, ever, ever going to touch the x-axis. Well, what kind of line can I draw through this point that's never going to touch the x-axis?
Horizontal.
A horizontal line. A straight line is not a good enough answer. A horizontal line.
Oh.
We don't need a bunch of dots here because we're just using the line.
Can we add 1 point if we want to?
Yes, you could.
Sure. Yes.
You
You
could
can
put.
put.
You could put
I got it. You can put as many points as you want. Thank you.
Okay.
All right. There's our line. Y equals 5. Now, I think I confused you guys yesterday when I said, oh, we can rewrite this as 0x plus 5. Okay, b is my 5. M is my 0. We put the 0 over 1. It's too much work.
Yeah.
If y is 5, go to 5 on the y, make a dot. If there's no x, this line's never going to touch the x-axis. If I expanded this out forever and ever, am I ever going to cross the x-axis? No, because these two lines are what?
They're horizontal and they're above.
Parallel. They're parallel lines, right? Which means they have the same slope. We'll get to that later when we talk about geometry.
Oh, no.
Now, number 6. What letter am I missing in number 6?
Y.
I've got no y value, or no y at all, I should say. But x is -2, so I'm going to find the x-axis, I'm going to find -2, and I'm going to make a dot at -2 on the x-axis. Now, if there's no y, I need to draw a line that's never going to cross the y-axis. Through this point, what kind of line can I draw so that it never touches the y-axis?
Vertical.
A vertical line, right through -2. There's the line x is equal to -2. All right? So when I was a student, the way that I always remembered this, because I always got confused which one was which, if there's no x present, my line's never going to cross the x-axis. If there's no y present, my line's never going to cross the y-axis. Okay? Any other questions on worksheet 10? Perfect. I feel like you guys are good on this, so we'll end it there.